Hello, this message is for all our attendees. Let's wait a few more, at least right for 5 minutes, so until others join. So it's five now. Let's start the meeting. Others will join when we after started. So good evening. First, big thank you for all our attendees, especially attending during this pandemic time. I am very pleased to be here today for address this gathering on behalf of Microsoft Student Partner Sri Lanka. Before start our proceedings, I have two announcements. Number one, the first, only producers and guest speakers can use the microphone and camera. If you have any question or any clarifications, please drop a message on live chat. Then I will direct those questions to our honored speakers. The second, in case if you want to record the today session, please drop me an email indrajit.ekanayaka@studentpartners.com. I'll repeat it again, indrajit.ekanayaka@studentpartners.com, and I will share the event link with you. So without wasting much time, let's introduce our guest speakers. Mr. Sajeetharan Sinnathurai, former MVP, current GDE and Cloud Solution Architect at Microsoft Sri Lanka, and Mr. Isura Nirmal, graduated from University of Colombo School of Computing and currently reading for his PhD at University of New South Wales, Australia. We're truly honored to have you both, sir. And so I honorably invite Mr. Sajeetharan Sinnathurai to deliver you Microsoft Azure from Rocky to Devstar. Sir, the mic is yours.
All right, let me share the screen first. Hope you can see the screen. Just verify.
No, we could just see you.
Wait, I'm sharing the screen. Wait.
We can see the screen now.
All right. First of all, good evening. Today I'm joining from Kandy, as you can see in the background, right? Hope you are doing well and safe. First of all, it's great to get connected during this unprecedented time. Thanks for joining today, and I will be talking about some of the interesting offerings by Microsoft Azure for developers to build and deploy your solutions on cloud, right? Thanks, Indrajit, for inviting me to do this session, and all the Microsoft student partners for your amazing effort to drive this or pull this event. I hope you all have basic knowledge on cloud computing, and this will be specifically on Microsoft Azure. On what are the concepts or what are the services available in order to deploy your solutions, right? Before we dive into slides, let me introduce myself. So I am working as a cloud solution architect at Microsoft, based in Sri Lanka. I closely work with software companies in this region, covering 9 countries, to build innovative solutions and help them with the digital transformation, to build innovative solutions using Microsoft technologies, to use the right practices as well as the services offered by Microsoft Azure. Apart from that, I am a developer. Whenever I get times, I contribute to open source and then build some of the interesting applications with my friends as well as some of the external parties. You can see some of the few communities that I run in Sri Lanka, which is NG Sri Lanka, dealing with Angular community in Sri Lanka, and also we recently started this Stack Overflow for developers in Sri Lanka. All right, before we get started, let me understand the audience. So this is one of the usual practice that I do in all my sessions, even if it's in person or even if it's a webinar through Teams. So let me navigate to the third slide. So let's start with a small game, which is about a quiz, right? So if you have mobile devices, you can take your mobile devices. And if you are using browsers, just join this game using the Kahoot.it. I have put up some basic questions or some questions about Azure. Probably you can start answering them, and then we will see how the knowledge level on Azure for the audience today. You can join by navigating to kahoot.it and then enter this pin. I'm waiting for a few players to join. Okay, Gihan has joined. Guys, I have this power bank, so whoever win this except Gihan, they will be getting this power bank whenever this
Me?
because you are part of the organizing team, right? So, and yes, so I will be giving one of these to the winners who are among those participants. I see 2 players. Okay, make sure you enter your name so that I will get to know you, right? Don't enter anonymous. Okay, there are 6. We will start once we get 10 players at least. How many participants do we have? Any idea?
Now we have 37 attendees.
All right, then we will wait for 15 players to join and then we will get started. Two more. Need 2 more to join so that we will have 15. One more. All right, so we have 15 players. Let's see who is going to win. Let me start with the first question, right? So this question is basically covering all the services available on Azure. So what are the offerings provided by Azure? If you have heard of, infrastructure as a service or platform as a service or software as a service, and whether it provides all those capabilities or services. This is a very basic, easy question. Let's see how many of you get it right. So there are 3 who have answered the question correctly. So it provides all those capabilities, right? It provides infrastructure, it provides platform as a service as well as software as a service. And then Hirenda is leading. So the points are based on how fast you answer or whether the answer is right or wrong. So the second question, how many regions does Azure has in public as of today? So how many regions are announced by Azure team right now? Whether it's 60, 58 or 55 or 54. So there are 2 who has given the right answers. Actually, it was 54. It was announced last year, but if you have seen the recent announcement, we have launched so many regions in Israel, and then in the recent times we have launched it in New Zealand, Poland, and there are a few more regions coming. So totally we are having around 58, and there will be 2 more coming in the coming months. So right now, Hiranda is leading. Let's see the third question. It's very easy. Azure DevOps can be used to deploy application to other clouds. The question is around whether you can use Azure DevOps to deploy solutions to other clouds such as AWS or GCP or even Alibaba or DigitalOcean, any cloud that you. It's a very simple question. I hope 15 participants who have given the right answer. So the answer is right. You can deploy to any cloud using Azure DevOps. So there are 8 who have given the right answer. So you have an Azure environment that contains 10 web applications, right? To which URL you cannot, you need to navigate to manage those resources. So if you are having resources in your Azure environment, what is the website that you will use to manage those resources? Whether you will use Stack Overflow, whether you will use AWS, whether you will use localhost, or whether you will use portal.azure.com. Yes. I feel sorry for those who have given the Stack Overflow and none of them have given AWS, unfortunately, and 2 have given localhost. I have added those answers for some fun answers, right? But the right answers is portal.azure.com. That's the place you need to go to manage your Azure resources. Still, Hiranda is leading. 5th question, best way to deploy an app that has an unpredictable spike using on Azure. So if you have application that handles multiple customers and you get a sudden spike based on the request, right? So what is the best way to deploy your solution? Whether it's containerization, whether it's serverless, or using virtual machines, you feel the question is too tough. So serverless is the offering that we are going to talk about today in detail. Is the best way to deploy your applications to scale, and then in order to handle sudden spikes, right? When it comes to cost as well as when it comes to scalability, that's the best way that we recommend. Let me go to the next question. Shehan is leading that. In 2nd place. So who is the CTO for Microsoft Azure? I have given some funny answers. Kiran the Scott, for Indrajit Hanselman, Chamu Nadella, and then Mark Rukovich. I guess this is very easy. Hope most of you get the right answers. Oh, only 2 of you have given the right answers. I feel sorry for who have given Indrajit as answers. He is not the CTO. He is just the organizer of this event, right? So Mark Ruzinovich, he's the CTO of Microsoft Azure. I would recommend all of you to follow him on Twitter or LinkedIn to see what are the updates that are coming out on Azure. One of the things that I mentioned about regions, right? So you can see his announcement that is coming around what are the new services and what are the regions that we are going to have it in Azure in the coming months. So I think we can see the winners. So 3rd place goes to Shehan. 2nd place goes to Jehan, and the 1st place goes to, I think, Hiranda. I will give this power bank to Shehan because I feel he's among those participants, right? And Shehan and Jehan is the organizing team. So you can reach out to me on anywhere, or you can meet in person to get your power bank. Let me navigate to the slides again. I hope this was fun, and then let me switch back to the slides. You can see the slides.
Yes, we can see.
So this. All right. So we talked about digital transformation, right? So I help these developers or the ISVs to build software solutions to do this digital transformation. So if you ask me what is digital transformation, it's about the capability of having or boosting your company to brand to a new level, right? Or burning the cost to a ground level so that you can manage your infrastructure or the applications, or you can handle your customers in an effective manner. Take for an example, you are able to attend these sessions through Teams. You are able to handle your courses online. You are able to submit your submissions, projects, do it online these days. But whenever I was a student, I had these difficulties. Imagine this COVID situation comes before 10 years, whether we had the right platform to do all this. The answer is no. So it's about making those softwares or making those tools available for your developers in order to deploy something quickly to the cloud, right? So if you think about some of those large companies, so we are talking about digital transformation, Airbnb, and then Alibaba Cloud. If you talk about Facebook, how they have been innovating using some of those ways that does the digital transformation. So when you talk about digital transformation, cloud comes in the first place. So you are talking about how you can empower developers to build solutions and then move to cloud. So today we are going to see how Microsoft Azure help these developers to build innovative solutions to support companies to do this digital transformation. So in this case of COVID, it's one of the effective sessions that you can utilize or to learn about Microsoft Azure. So business is powered by applications, right? If you talk about business, so if you talk about anything in today's world, everything is running on software. If you take how we are interacting right now, it's through Microsoft Teams. It's again a software. How we are connected, so through phones, through Facebook, through Twitter, everything is dealing with software. So innovation and application modernization revolves around how fast you can build things to production quickly and effectively on cloud. So Microsoft supports in several ways when you're building applications that scales, how you can serve millions of customers, how you can seamlessly interact with those users across different countries in the world, how you can build applications without downtime. So that is one of the other important thing. If you're having application that should not have any downtime in order to serve those customers. If you have seen in the recent times during the COVID situation, there are many retail industry. I mean, there are many software that deals with retail industry. They have been facing a lot of challenges to cater these customers online, right? So you need to handle that in terms of dealing with your customers without any downtime. You need to have in mind about the scalability, about the availability, about the resiliency in order to cater your customers before you design your applications to the cloud. So if you've seen the evolution of application platform, I have been a developer from those era where we deploy applications on-prem. So when I was a developer back in 2010, I had to write softwares that are deployed to on-prem, which are physical machines deployed to multiple customers. So there were a lot of resources involved in maintaining those resources. So I had to spend nearly 4 days to fix a bug and then copy and paste those DLLs to another environment. So we give those DLLs to an engineer or implementer who take those DLLs and using a pen drive and then deploy to those resources. What if the server goes down? So you get a lot of questions like, what media should I use to take a backup? How long does it takes to spin up those environments? So there are a number of questions that came into mind in those on-prem deployments, right? And when you talk about cloud, when we navigate to, when we move to the cloud era, we had infrastructure as a service. So that provides some flexibility in order to, when it comes to maintenance, because it provides a way to spin up your environments using those right infrastructure. But when it comes to maintenance, how do you apply those patches to those servers? How do you take a backup? So those questions were not still answered, right? So which OS they need to use? So these questions were answered by, PaaS capabilities, which we call as cloud native capabilities. So this is provided by most of the cloud services these days. If you take AWS, if you take GCP, if you take Azure, if you take any of the cloud, PaaS is one of the important things that all these clouds are driving in order to make those developers to develop on their platform. So, but it also answers certain questions like, what is the size of servers that my business needs. So if you are spinning up some of those resources, you need to scale up those resources. You need to add additional resources in order to scale those applications in order to cater those users, right? So there are cloud vendors who are providing those capabilities using the patched options. But if you see the feature, we are moving to serverless. That is about building, future-proof applications which cater all these questions answered. I will be talking about in detail. But if you see the evolution of software development and how Microsoft Azure is helping these developers, it has been in the dramatic way, right? So software development continues to evolve, and Microsoft has been the pillar or been there for a long time, enabling these developers to build softwares. And if you have seen from the times of Steve Ballmer, who talks about developers, and then through the times of Satya Nadella, we have been investing a lot of tools which are focused on developers to build solution innovatively. And we have been known that developers are going to be the key resources that are going to support us to drive this cloud app modernization. And then if you see evolving developers in your organization at the pace of software also evolves, right? Who are the future success of your, any organization that you take? So if you see, we have been helping the developers in terms of open source software, in terms of building the right practices around DevOps, in terms of computing, cloud computing through Azure, and then low code extensibility, which was announced in the recent times. So if you are a developer, or if you are not a developer who is called the citizen developers, who doesn't have much background on those technical capabilities, so we are providing or supporting those users as well in terms of building applications innovatively. So as I mentioned about Azure, so there are so many services that we have around 200 plus services that let them quickly and easily build, to build applications or start with building your applications to the cloud. We offer unique end-to-end solutions that help your talent pool to multiple the number of peoples and the solutions using those a number of services that are dealing with cloud storage, infrastructure. You'd call any device, we are providing those services. Azure has a powerful set of highly engineered services. When you talk about tools, starting with Visual Studio, and we acquired GitHub back before 2 years, there have been a lot of announcements that are coming in the recent times. And if you talk about Power Apps, Power BI, that has a built-in capability and then automatically handle those security and then updates automatically if you take all these services, right? As I mentioned, we have 58 plus regions announced worldwide, and there are 92 compliance of the security standards, which none of the other cloud provider has. So if you take the number of regions combinedly, which is more than AWS, or combinedly put together AWS or GCP has, which is one of the growing strength in Azure. That we see in terms of cloud. So when you talk about applications, it's important to see how you are modernizing your applications to cater this cloud world. If you take Microsoft, we have more than 3,500 applications which are built internally, and then to external customers as well. And the evolution has been in 3 phases, right? So Microsoft as a company, as I mentioned, we have a lot of applications. So we have seen there are certain applications that we cannot move because those are monolithic applications, and it takes a lot of time, a lot of effort to migrate those applications to cloud. So you need to make a decision whether you want to take those applications to cloud or not. That is the first decision that you need to make. There are certain applications that cannot be ported to the infrastructure as a service, you call lift and shift. There are certain applications you need to refactor using containerization technologies, which I will be talking about, and then you need to do some refactoring in the code in order to migrate to cloud. So you can see the distribution. There are less than 5% of applications that we were not able to migrate to cloud. There are 35% of applications that we were able to migrate to cloud using infrastructure as a service, as well as using those containerization methodologies. And when it comes to cloud native capabilities such as I mentioned about PaaS offerings, right? So there are 15% of applications which were able to re-architect or add those capabilities dealing with AI, machine learning. Those are provided by the cloud vendors in these days in order to migrate to cloud. And there are 30% of applications that we need to rewrite in order to take that applications to cloud. So there are three terms that I talk about. One is the rehosting, one is the refactoring, and the other one is the re-architect. So if you are a developer, you need to think about these three factors, whether you want to rehost a do a lift and shift, whether you want to refactor some part of the code, and whether you want to containerize and then move it to cloud, or you want to re-architect, rewrite the entire application in order to move to cloud. There are certain benefits that comes with all of these methodologies. I will not be talking in detail, but if you ask about in general, it provides improved performance, scalability, and then resiliency. And also you can deliver the capabilities or the features quickly in order to cater your customers. So if you talk about rehosting your application, we are providing a VM. So if you talk about GCP, it's called compute. If you talk about AWS, we call it EC2 instances. It's also available in Azure in the forms of VMs. So you can spin up a VM that would run your application in any form. So you can just spin up, do the auto scaling. You can have a VM in availability zone in order to handle those, availability. And then when you talk about app modernization, we provide those containerization methods through, containerization methods that are available in Azure, which I will be talking about. And then we have a method to re-architect using microservices. So you can convert your monolithic applications into multiple chunks and divide those features into separate services and build your application. And then serverless is one of the trending thing these days. You can cater microservice applications as well as, if you're building capabilities around AI, if you're building capabilities around event-driven architecture, say if something happens, you need to trigger something, then you can go for serverless, which is built per consumption. So it depends on how much you are consuming, and the charge is based on the consumption. And the final thing is the SaaS. So if you follow all these practices, you can put it, Microsoft is also providing so many cloud services, cloud offerings as a SaaS model you can use. So these are the benefits that, deals with cost as well as availability when you are thinking about moving applications to the cloud. I think I will take much time, probably 15 minutes more than actual time. Hope that's okay with you guys. So when you talk about modern application patterns, I talked about containerization. So these services enable you to adopt containerized serverless computing architecture if you are building new applications. With Azure, if you are a developer, you can build cloud native applications using those containerized methods, which I will be talking in the coming slides. And also Azure supports and provides all the building blocks. If you're a developer, you can use the Devops tool and Visual Studio Code to you do the development and push your code to the cloud using one button click, which I will be showing in the demo. When you talk about, I will be mainly covering modernization part, because I don't want to talk about, lift and shift using those VMs to deploy your application. When you talk about, PaaS offerings, what Azure provides, if you're a developer, these are some of the few services that you need to be aware of if you're an application developer. Let's start with Azure App Service. So if you are familiar with any of the cloud vendors, they provide their own capabilities to deploy your application. So Azure also has one of the easiest way that you can take your application and put it on cloud. It's called App Service. So you can quickly build an application on any cloud, any platform, on any framework or any platform, and you can spin up your instance, app service instance, and then deploy your applications, which talks about high productivity. So as I talked about, it could be on Node.js, it could be on Go, it could be on Docker, it could be on Ruby, or it could be on Python. And then you can have something like staging environment, right? So assume if your application goes to production and there are a number of users who are accessing it, and you want to have a zero downtime, then you can do a slotting environment. When you are doing a deployment, you can make the slotting environment comes into production, when you're doing the deployment, and the production can go offline. So you can route the users who are actively accessing your website to access those slots. That is also possible. And then when you talk about testing in production, you can do that through spinning up those different app instances in order to do your testing. So we are providing something called dev test that offers your dev, in order to do your load testing and things like that. And the final thing is you can publish your app on the app marketplace so that it can immediately deploy to app service from their own. And then it provides a fully managed infrastructure. You talk about auto scaling. So auto scaling comes in two ways. One is called a scale up and then scale out. If you ask about the different scale up in the, if you ask me what is scale up, it's about increasing the number of resources. It could be the CPU, it could be the memory. So it's about increasing the resources. And if you talk about scale out, it's about increasing the number of instances in order to cater your customers. And then high availability is one of the important aspects that is provided with auto patching. So you don't have to worry about applying those patches. And then it comes with reduced operational costs. So if you are deploying your application on VMs, you need to worry about the monthly payment. But in terms of app service, you will have a limited pay cost when you are deploying an app service. And then automatic backup and recovery, that also comes into place. Again, a lot of additional features available based on the plan that you choose. It comes with CDN, it comes with hybrid support if you have a hybrid way to access your on-prem environment and if you want to deploy cloud. And then it comes with Azure AD integration in order to integrate those security features with your application. And then I talk about security and compliance. There are 92 plus compliance offers that are available with Azure. So, and the second point, which is one of the interesting subject for me as well, containerization. So let's take an example. I assume most of you are students and you might not be familiar with containerization. Let's take a simple example to understand this containerization model, right? You plan to rent a house in Airbnb or even in Sri Lanka if you're going for booking.com. You are getting a house. There are 3 rooms and it has only one kitchen and a cupboard. You're going to share with 3. It could be a woman, it could be a guy. But those partners who are not agreeing to share their cupboard or the kitchen with you. So in that case, what is the solution? So the room or the house owner has to come up with separate cupboards or the separate kitchens, right? So that is a problem and that's a solution, right? So I talk about replace these users or the persons as an application that you are building. So in order to manage those dependencies, I talk about kitchen as well as the cupboard. So what containerization is going to do is it's going to provide a solution that you can have those dependencies as a package. So it's about a package that it's about the packaging your application and all its dependencies together in the form of container to ensure that your application works seamlessly across any environment with all these dependencies. So your application could be on any language. Your application would have different dependencies that talks to different external libraries. So you don't need to worry about the environment. So this is one of the problem that I faced as a developer back then in 2010. So you don't have to worry about it worked on my machine. So there is one of the famous meme available, right? It worked on my it worked on my machine. And then you don't have to complain your testers that it worked on my environment. So if it works on your environment, it should work on different environments. It could be on cloud. So this can be achieved with containerization methodologies. So Azure provides different containerization offers that comes in different forms. So if you want to deploy your application as a container model on app service, you can do it. If you want to deploy your application to Service Fabric, which provides a clustered way of deploying your applications, which I will not be talking in detail, but you can do it through Service Fabric. And then Azure Kubernetes Service provides a way to deploy your containers through different as a distributed environment in order to manage scalability, and then it provides auto maintenance as well. And then we provide something called container instances. So if you're having a small application that you want to take it to cloud, when you talk about low cost, you can go for container instances. So if you see a sudden spike, that is one of the recommended way that we provide to the customers or even developers. And you can implement container instances with Azure Kubernetes service as well. We are provided with virtual kubelets that comes as a backends to your Kubernetes environment, so that you can extend your applications to deploy your applications through container instances and then scale it. And then you can talk to external third-party APIs as well. You could have those container images on Docker or any other third-party environments. You can still pull those images to your container instances that is running on Azure and then deploy it. So it becomes so easy because we provide those several flexibilities for developers to deploy your applications on cloud. So I need to talk about Azure Kubernetes Service because I am very much interested in these two concepts. One is serverless and the other one is the containerization. To understand Kubernetes, think about scenario of a football team. If you are a fan of any football team, they would have different players, right? Assume 11 players who are playing on the field. Assume those are containers in terms of applications, and suddenly one player got injured. So what would happen next? There will be a person who will be replaced by the account manager from the football team, right? So the football team manager, the physio who are orchestrating these players in order to perform to their full level, that is called the Kubernetes environment. So in order to orchestrate your application through containers in a distributed environment, so you can consider this example as a Azure Kubernetes service. So if you take Kubernetes, that was announced back in 2012, I think, it was a non-managed service, but in Azure we are providing a managed Kubernetes service in order to manage your application in the cloud. Sorry. In the cloud in a distributed environment. So you don't have to worry about application patching. You don't have to worry about scaling. You don't have to worry about, automatic updates. You can use the Kubernetes cluster in order to manage those distributed environment. And it comes with absolutely no cost. The underlying VMs which are running your applications are going to be cost. But if you see the control plane which is accessing those applications, it comes with free of cost. So if you are a developer, I would highly recommend you to go and see Azure Kubernetes Service in order to deploy your application. So this is one of the end-to-end solution that we are providing with Azure in order to develop using VS Code, and then you can push it to GitHub repo or Azure Devops repo, which I will be talking about, and then you can deploy to stage environment. You can validate your test using staging environment. You can switch it to production after you publish your application. You can do some monitoring through App Insights, and then the users will be able to access. So this is kind of the end-to-end environment if you are deploying any applications on Azure Kubernetes Service. And then finally, I want to touch upon Azure Cognitive Service. So if you are a developer, who doesn't come from those, AI background. So if you are a developer or if you are an end customer who doesn't know about any of those development technologies, you can use some of the tools that are available in Azure. Starts with Power Platform and then Azure Cognitive Service, which provides a number of APIs to play around and those, and to build those artificial intelligence capabilities, starting with vision, API, vision, speech, or web search, or language, or anomaly detection. I'm not going to touch on these capabilities, but there are a number of samples and then documentation available. So when you talk about serverless, the interesting topic that I will be diving in detail, which could be anything that serves on web or mobile or mixed reality or Internet of Things, or you can talk about media. So with Azure, you can bring the power of containers, databases, and AI to provide end-to-end applications to your customers. So what is serverless? So if you ask me what is serverless, it doesn't mean there is no server. There is a server that is managed by the cloud provider, but you don't have the visibility to access those backends. So if you are a user, you are deploying an application to the cloud, If you are deploying it on VM, you will have the full control to access that particular VM. But if you are going for any of those serverless offering, it is going to be managed by your service cloud provider, which you don't have access. You will just get an endpoint where your application is hosted, but when it comes to scalability, when it comes to availability, it is completely managed by the cloud provider. In Azure, we are providing different cloud services or offerings that provides with serverless. So when you talk about event driven, so what is event driven? If you talk about event driven, if I have to put it in a funny way, assume you are in a bus stand, and if you see a beautiful girl, you will get triggered to follow her, right? So you tend to do something based on some action. So if I have to put it in a business way, assume you are getting an email. You need to do some action based on that email. Assume your manager is telling you to do some task based, particularly mentioned in the email. So you can consider this serverless as a concept if you are doing those event-driven application. And if you want to take your application quickly to the market, in order to consider the cost and also the time taken to deploy your solution to cloud, you can go for serverless. And also it doesn't take any time to manage your infrastructure, and you don't have to worry about scalability as well as availability, which is handled by the cloud provider. And it comes with cost reduction, so you don't have to worry about the cost that is needed. Again, one of the examples that I need to provide, assume if cloud computing was a transportation. So to understand the differentiation between infrastructure as a service, platform as a service, and then serverless. So if you can lease a car, then the owner has to take care of the maintenance, right? So you can consider deploying it in a VM. So maintenance comes to the owner. You can take IaaS as example. And then when it comes to PaaS offering, you are renting a car, but you are paying for having it around, and then even when you are not driving, you need to pay for that. So that we are talking about PaaS. And then serverless, assume you are using, booking through Uber, and then you are doing right through PickMe, then you are paying for what you use, right? So it's about talking about a differentiation between those IaaS, PaaS, and serverless. There are serverless offerings available in Azure. When you talk about databases, we have Azure Cosmos DB, which provides multi-distributed and then scalable offering for large-scale enterprise applications. Also, if you want to build a small application, you can start with, serverless, which supports mainly 4 APIs, starting with, SQL, MongoDB, Cassandra, and then Graph API. I will not talk much in detail, but if you have any questions, you can talk to me in person. I think I'm running out of time. I will quickly go through some of those serverless offering. So when you talk about serverless offering, we are having serverless functions, which comes in the form of Azure functions, and then we have logic apps. And then if you are dealing with multiple events, or you are talking to high scale application, then you can go for something called Event Grid and then API Manager in order to manage your API endpoints. When you talk about serverless, we are providing end-to-end support. It starts with application integration, ID integration, and then local development. You can push it to cloud and then do those end-to-end testing, and then you can do the auto scaling monitoring and things like that. When you talk about Azure functions, it's about receiving those events, and then you can write your logic in as Azure function, and then you can put those outputs as a binding to any of those cloud service available in Azure. So assume if you're uploading a file to Azure Blob, say if you want to do some actions so then upload, then you can do the image scanning, you can do the OCR recognitions on the file upload using those cognitive service. So this is one of the examples that I wanted to provide, but there are several sample cases that you can take. Say if you want to do background scheduling, then you can go for which is based on timing, then you can go for serverless offering. And if you want to do real-time stream processing, then you can go for serverless. And if you want to do mobile app backends, so which deals with a lot of APIs, then you can go for serverless. And the second thing is the logic apps. So if you are developer, or if you are a citizen developer who doesn't have much ideas on what are the APIs available, or you don't know much about the technologies or the frameworks available, then you can go for Logic Apps, which provides a way to build your applications quickly with drag and drop features available. So you can just drag and drop and then make those connectors, which deals with we have more than 200 connectors which deals with different databases, different offerings. You can build your application. And finally, I want to talk about DevOps. Assume if you are a developer, what is the if you are a person who is coming from the construction background, what is the average time taken to build a building? In Sri Lanka, obviously, it will take more than 3 months. But if you consider in USA, they are doing it in 2 hours. So if you are a developer, you need to be effective in order to deploy your application whenever customer wants to deploy your features or fixes quickly to cloud or to any environment. So that can be achieved through Azure DevOps. So DevOps is the process of merging or uniting people, process, and the technology. People, in the sense the developers and as well as implementation engineers. You can take anyone as example, and process in the sense the two the right practices. It could be Agile or Scrum that you follow in your development environment, and then the technology. So Azure DevOps, and then there are different technologies around it in the open source world in order to deploy your applications to the cloud, right? So with Microsoft, we don't have engineers. We don't have someone in the name title called testers. There is no testers careers available at Microsoft, because if you are a developer, you need to ensure that you are developing it correctly, you are testing it correctly, and you are deploying it correctly. So Azure, again, it comes with GitHub integration. So we closely work with GitHub team in order to cater developers in order to deploy your application quickly. So we are providing a single authentication to manage these two environments, and then you can have those end-to-end traceability through App Insights, and then you can have those security and then vulnerability scanning on your code through different services. So if you talk about DevOps in Azure, there are different offerings available. I don't want to talk much in detail. You can have those backlogs if you are dealing with any application development. You can monitor your application, and then you can have those artifacts if you are building any applications as a package and you want to explore to outside who are not in your company organization, or if you are a developer, you want to publish your package as a NuGet package, you can explore Azure artifacts. And then App Center is another thing. If you're a mobile developer who are dealing with iOS and Android development, you can explore the App Center in order to deploy across multiple devices, in order to test across those devices, and have those CI/CD, continuous integration, as well as the deployment in place. So again, in GitHub, we are providing something called GitHub Actions and the package registry, and there are a number of features available. If you have seen the GitHub satellite, which was happened in 2 days before, there are a number of features available announced in the GitHub, right? And the final thing I wanted to touch upon is the App Insights. So if you're a developer, it's about monitoring your production environment. So you need to make sure that you should be able to fix whatever the issues that is happening in production environment and then deploy it quickly. So if I'm a customer, if I come and ask you, hey, this error is happening on this particular scenario, then you should be able to identify that particular error through Azure App Insights, and then it will navigate to what are the dependencies, what is the particular code that is causing that issue. Again, I want to touch upon GitHub. We have more than 50 million developers who are accessing or developing solutions on Azure through GitHub and also on open source. This is one of the important slides. If you didn't understand any of those concepts that I talk about, I would ask you to focus on this particular slide. You can use this. I'm not going to go through in detail, but this is available in this particular URL. You can go through. So if you're an app developer, you need to go through this flow in order to deploy your applications to cloud. Whether you want to have it as a lift and shift, then go for virtual machine. Whether you want to deploy it on different platforms quickly, go for app service. And whether you want to have those control or the portability, then you go for container instances, and then if you want to have a multiple heavily performing application which deals with gaming or AR VR high performance workload, go for Azure Batch. And then if you want to package your application, go for Kubernetes containerized environment. And if you want to go for event driven application, then go for Azure Functions. I hope you got some idea from this particular slide or my session. How much more minutes I have? I want to do a demo as well, but I will quickly do it. Can I take 15 minutes more?
Yes, it's fine.
All right. So I want to build a quick demo and show how you can utilize those services in order to build your applications, right? So this demo consists of several services in Azure, and you can simply build. But if you ask me, I was a developer before 5 years. I had to build same applications using Python as well as some of the machine learning tools in order to display a dashboard on sentimental analysis, how a user react to particular incident on different social mediums. So I have taken COVID as a scenario in this particular scenario. I'm going to build that application quickly and showcase how you can deploy that application on Azure. So this is my Azure portal. You can see I have different resources, but let me quickly go to create a resource group. So if you're not sure what is resource group, it's about packaging your resources as one in order to have those maintenance easily, right? Before that, I want to show up something. So if you're a fresher on Azure, this is one of the service that that you want to start. There is something called Devops starter. If you are from different cloud, if you are familiar with different cloud environments, or if you are not familiar with Azure, start using free subscription for students, and then start to this come to this particular Azure DevOps starter. Then you will be able to see different frameworks that are available in the cloud, or if you're a developer, you are familiar with all of these technologies. As you can see, you can start with Node.js, Go, and then you can bring your own source code. And then if you want to build a simple app, I will start with Go application. If you're an open source guy, then you are much familiar with Go. So I will, and then you will have the option to choose where you want to deploy, whether you want to deploy to Windows App Service, or whether you want to deploy to Kubernetes, whether you want to deploy to containers. So you can just click on those, and then you need to pass those details. It will automatically create those resources, as well as something called source code control for your application quickly. So this will take few minutes to create those resources, and then I'm not going to do it now, but I just want to highlight the fact that if you are a developer who doesn't have a Azure background, this is the place to get started in order to deploy your application, right? Let me go to my demo. I'm going to create a logic app first in order to showcase. So the architecture is very simple. Have to draw a whiteboard. I thought of using a Windows whiteboard, but due to the time, let me pull up whiteboard. My drawing sucks, but I hope you will get something. So let me draw, this is consider this as your application, which consists of logic apps, and then I'm going to talk to cognitive service in order to do the sentimental analysis, whether it's a positive or negative sentiment. So we are going to fetch those tweets from Twitter. Assume this as Twitter. I'm drawing a bird. Yeah, assume this as Twitter. So there are tweets coming from different users. So we are going to fetch those tweets from the logic app, and then analyze those tweets using the cognitive service, whether it's a positive or negative, and then we will pass it to Azure function, which comes as a serverless offering, which I talked about, in order to determine this sentiment score of that particular tweet. The score will be passed from this particular cognitive service, and then we can pass this score to Azure function in order to determine the sentiment, whether it's a positive sentiment, whether it's a negative or neutral sentiment. And finally, we are going to write this to Power BI in order to visualize this on a dashboard. This is the overall architecture. My drawing sucks, but I hope you got this basic idea on what we are going to do, right? Let me create a logic app. I'm going to create a resource group first. I can create a new resource group. I'm going to name it as MS Jams COVID, and then logic app is also same. I'm going to deploy it on Southeast Asia because this is where the latency is very low. Because if you see, India is the closest region, but Southeast Asia, the data center resides in Singapore. That is the fastest, way to access your application. So I have created the resource group. I'm going to Logic App. So Logic App provides two ways to create your control or the logic, right? One is using the designer, and if you're a super powerful developer, you can use the YAML. You can use the code in order to create your application. I am not a pro developer like you guys, so I will use the designer in order to create my application. I have the first step is to navigate and create, login to your Twitter. So I have created the first step as whenever someone posts a tweet, we are going to fetch the tweet. So there are a few steps that you need to configure. The frequency, how frequent you want to get those tweets. So I'm going to access these particular tweets that are coming with that hashtag COVID, and I'm going to access those tweets per 15 seconds, right? So I'm going to have it as 15 seconds. And the next step, as I mentioned, I'm going to pass it to cognitive service. So I need to create a cognitive service in order to pass these tweets and get those sentiments, right? So I'm going to create a cognitive service. Oops. It is going to probably I can use the existing one. So I have already created a cognitive service. I'm going to get those keys and the endpoint. If you are doing it, you need to create a new cognitive service. So I'm going to use this text analytics that comes with detect sentiment. So we are going to pass this tweet, the sentence that comes with the tweet, and we are going to detect the sentiment. I need to pass the connection name. So I am passing it as MS Champs COVID, and the account key is going to be the same, which you can copy from these cognitive service, and the endpoint is the endpoint that comes with your cognitive service. I have configured the second step. So this is going to fetch those text of the tweet and then going to analyze the score of the sentiment. So you need to configure the tweet that you want to pass as an input. So tweet text is the input that we are passing, and then I'm going to create the next step. As I mentioned, we are going to pass it to Azure Functions, right? Since we are running out of time, what I'm going to do is I'm going to show how to create that Azure function. I'm going to open up Visual Studio Code in my local environment. You can see the VS Code. Oops, it's taking few minutes. So you can create a new function by using Control-Shift-P if you have installed the Azure Function Code tools in your machine, or you can use the Visual Studio Code. The first step that you need to do is create a new project, right? So I'm going to create a new project. I have already created a folder named serverless. It is going to open up that folder. It is going to take few seconds, as you can see. It's activating those extensions, so it might take few seconds to. All right. Hope it should be fine. Let me open up a new instance. you know, live demo always fails. So let me create a, oops, I clicked the wrong button. Create a new project. I think it's because of the internet, it's trying to activate those extensions, and it's taking a few minutes. All right, what I'm going to do is I'm going to show a new function that I have already created. Let me show, because it takes a few minutes to set up my environment. But what I have done is I have created a new Azure function which is written on C#, and then it is going to do a simple logic, right? So you can see that you need to install the C# code extension in order to develop this function. And also you need to pass those parameters. What is the authentication mechanism? So I have selected it as anonymous, and then you need to pass whether it's a HTTP trigger, what is the type of trigger that you want to have. So in this case, I am going to build it as a HTTP API. So I have given as HTTP. So this is the logic. So your template would look like this, and then I have passed the file name as decide sentiment, and then you need to, you know, create your logic. So it is going to get the score as a request. So we are going to get the score here, and then, you know, we are declaring the default sentiment as green, and then we are getting the score from the input that is being passed from the cognitive service. And if the score is less than 0.3, then we are saying it is negative through the red, red sentiment. And if it's between 0.3 and 0.6, we are showing it in yellow. And then we are just sending it as a response using the HTTP source status code OK, and what is the sentiment. And once you're done with this function, you need to deploy with this particular command, deploy to function app. So I have already deployed this function to Azure. I'm going to configure that function. So as you can see, the third step is configuring with Azure function. So you can see my function is already deployed. So I'm going to use the sentiment detect function in order to get the score from the cognitive service and then determine the sentiment, right? So the request is going to be the score that we are passing as an input to Azure function. And then the next step is going to be the Power BI dashboard. What you need to do is you need to create a Power BI dashboard, the data set. So you can go to Power BI and then create a new data set or workspace. I already have a workspace created. I'm going to create a data set in this case. It's fetching some of my works as well, so let me wait for that. All right, so I already have my, COVID-19 workspace or the report that I have already created. Okay. This is the endpoint that I wanted to see, but if you see, these are some of the data set that I have already created. So what you need to do is you need to create a new Word data set from this Power BI. I will show what I have done it. So you need to create a new streaming data set with these fields. What is the tweet? What is the user? What is the location? What is the time it got created? What is the score? And what is the sentiment? Also, you need to enable the historical data analysis in order to, have those data stream in real time. Once you're done with it, you need to go back to Power BI and add this step, add rows to data set. I need to navigate, I need to log into Power BI. I will take another 5 minutes. I know we are running out of time, but I will take 5 minutes. So my workspace is Power BI and the data set is COVID and the table is real-time data. This is the final step. What you need to do is you need to map those data with the data that we are getting in real time. So tweet is going to be the tweet text. And then created time is going to be the created date time. User is going to be the name of the user. and the sentiment is going to be, the body of the function that we are, the body that is received from the Azure function that we deployed, and then score is going to be the input that we are getting from the cognitive service, and the location is going to be the location. We are done with everything. We are good with all the steps. You need to stay safe and then run this logic app. That's it. One more step that you need to do is from the Power BI is to create your own report. So you can create different reports, based on different insights. I have already created, because it might take a few minutes to create, the reports. I'm going to show what I have already created. So you can see the data is coming in live around the, before showing it, I have 54, but when I start streaming the data, you can see the tweets coming in live. I think, yeah. So we have around 1,039 people who have tweeted negatively, and then there are a lot of people because we have seen an improvement in the COVID situation, and then you can see the distribution, right? Also, if you want to debug your logic app, you can always go and see whether it got succeeded, what is the tweet that has come in, what is the time, and then things like that. So it is so easy to build complex applications using, these offers that are available on Azure. And if you're interested to know how to implement, I have already written a blog post on how to do this step by step. You can go and read in this particular URL. And also I have this source code available on the Azure function, available on GitHub. So you can go and, put a star and also fork it in order to have in your own environment. Finally, I want to give few tips for the students who are out there. So there are a lot of features available on Azure, a lot of offerings that are coming with Microsoft. If you're a developer, go and register on MS for the Microsoft build, which is happening in 2 weeks. There are a lot of new features which will be announced, a lot of school sessions that are coming out. Register for it. And if you are a developer from different backgrounds, start using Azure. You can always start it freely. We are giving it for free for students, worth of $100, and then for others $200. But you need to swipe in your credit card just for the verification. And then if you have any questions, anything related to any fun technology things, you can talk to me. And also I'm available on Stack Overflow all the time. You can reach out to me on Facebook. And if you have any memes regarding your friends, reach out to me. We can make them popular. And then rate my session on this particular URL. I want my feedback in order to improve my upcoming sessions. And Microsoft student partners community, they have been doing a lot of engaging sessions, active contributions on this student community. Join their meetups. It's not only about us talking, coming and talking, sharing our experience. You guys also engage, share about your experience. It could be on anything. It could be even on other platform. It could be on other, open source things like that. And then join Stack Overflow Sri Lanka. I talked about memes. You can post your memes out there and talk about different technologies, things that are happening in Sri Lanka. This is just to, encourage the developers to contribute and, bring the developer ecosystem to a different level. All right, guys, I think I was making you to sleep. So if you have any questions, you can post it on the chat. I have taken extra 15 minutes, but I think it's okay since you got something. All right, I will be able to answer a few questions, but if you don't have any question, thank you very much for having me. Thank you very much for the opportunity as well. I hope I made some sense to this session as well. Hello, Sajeetharan, good evening. Does Azure provide CPAP plans for students who want to do provides? Okay. I want to take up this question by Sehan. It's about credits for students. So there are a lot of offerings available for ISVs who are building solutions for customers. We have something called startup programs, scale-up programs, and during these COVID times, there are grants available for even for students who are building solutions. So it's about not using the cloud, right? You can always read and read and learn about Azure, because we are providing aka.ms learn, which comes with free sandbox environment to have those capabilities. So you can do the same things what you are doing on cloud using those sandbox environment. But if you're building application, yes, we support those developers who are building industry level applications. It's not about giving credits, right? It's about building those applications to the market. I know there are a lot of other cloud vendors who are providing free credits, but it's about building those applications in real use cases. And also, if you're a student, you can go and learn about new things using aka.ms learn, and a lot of other free resources available. So start utilizing those. So you don't have to worry about credits, if you ask me. And yes, there are credits available for students. And if you have a specific application and if you need credits, you can reach out to us. I will be able to support from that aspect. How can I access the presentation? You share the present. I will give these slides to the organizers, so they will be able to share. Make sure you rate the session, and then it's like asking people to subscribe. It's about getting the feedback, right? So make sure you give those feedbacks. Why doesn't Azure support taking snapshot of VMs? I don't think so, because you can take snapshot of VMs. Like for example, for VM using Hyper-V VMware. I think that question, it deals with particular scenario. I don't want to talk here and then read much waste of time. But in general, we provide offerings to take snapshot and take these images in order to deploy across multiple instances. But I will take your question offline. You can reach out to me. I think it's again asked by Shehan. Do we have any other questions? You can ask, put it in the chat. There are 5 upvotes on that. Probably I will take that question because it might take a few minutes.
So
you can give the feedback. What is your meme target? Okay, that's a very interesting question, right? So if you see, there are upvotes also. So if you see, I have been, I started this Stack Overflow Sri Lanka community back in 2018, and we had interest. I mean, we had few sessions initially, but after that I got engaged in different things, and we didn't have time. But before during this COVID time, I was finding enough time to do my own things, right? I was getting bored doing few things at home, doing homework and things like that. But I wanted to make something different to the developers, so I formed a team who are contributing in different communities, and then we came up with different posts initially, and then we saw, okay, what is the engaging things that would get different audience to this particular community. So I saw this in different programming forums that they had this, if you talk about Reddit, they have been posting different memes around developers. That even on Twitter, if you see developers who are having most number of followers, those are the developers who are posting these funny things about technologies, right? So it's about getting those users initially. So we need to target at least 4,000 users by the end of this COVID situation. And we are on target. We are on actually reaching the target, if you ask. So it's about getting those users initially, and then I will make sure that we are providing the right content to developers who are engaging. And if you feel that it's funny, I will make sure that it's not happening again. I will make sure so it's not hurting anyone out there. So that's one of our motive. I hope I answered the question. If you don't have any other question, we will move to the next session. Thanks guys for your time. I hope you had a good session. Yeah.
So Mr. Sajeetharan Sinnathurai, thank you for your informative session, and I think everyone get something to move Rocky to Devstar, as the name implies. So I think you, Shehan, and other questions has got the answers. So let me, without wasting more time,
Indeed, we lost you. We can't hear you. Indeed.
Hello.
Yeah. Now we can hear
Yes.
you.
Yes. Unfortunately, Mr. Isura Nirmal unable to join through his machine, so he will carry out the session through my mic. So it's the next session will be about introduction to deep learning by Isura Nirmal. So mic is yours, sir.
Yes, Indrajit. So, am I audible?
Yes, you are.
Yeah. Let me start the presentation. Okay. So, hi everyone. Good evening. So, I'm Isura Nirmal, and I'm currently a PhD researcher at University of New South Wales, Sydney. And mainly my research areas are wireless sensing and deep learning. So, so sorry, there was a small technical glitch. So Indrajit kindly offered his account for me to log in. So I think now that it's sorted. So first I have to thank Indrajit and all the organizations for inviting me to deliver this session, because I'm privileged to deliver this, because about 7 and 8 years ago I was a participant for the MS Champs, but it's a privilege to present something for everyone, and I hope this will be somewhat valuable for those who are joining from industry, as well as from undergraduate students or postgraduate, because deep learning is considered as one of hottest topics in the current computer science and IT discipline. So I hope to balance my session to give you some kind of theoretical understanding of the deep learning, as well as some kind of hands-on session. Because without some theoretical understanding, it is very hard to express this idea related to the deep learning. And so I'll try my best not to be boring, and I try my best to be not to deliver you another lecture. So there will be a small demonstration session available at the end of the session. So without further ado, let me move to the topic of what is deep learning. So artificial intelligence, I think this is something you guys have already have some kind of an understanding. So what is artificial intelligence? So first we have to ask a question: what is intelligence? So intelligence is ability to process information in order to make decision. So we have our own knowledge to make our decision as human. So artificial means creating an artificial algorithms to achieve this task. Okay, so in the artificial intelligence, we can consider machine learning as a subtopic, sub area. So in the machine learning, we are teaching an algorithm how to do this without explicitly programming it to do. Okay, we are only teaching how to do it, and after that, when the machine learning algorithm learns it, it works without needing any programming. So the deep learning is a subset of machine learning. Okay, so deep learning can automatically extract these features or the information from the raw data. So as you can see, deep learning doesn't require a lot of human intervention, because it can learn the complex features, complex information to make the decision automatically. So that is why deep learning is very deep learning is a very hot topic in these days, and it is a very powerful tool. So moving on to why deep learning now. Okay, so why this is talking nowadays? Sorry, why deep learning? So I talk about these features. So Mostly, we have to talk about deep learning as compared with the human cognition or how human learn. Okay, so when I ask someone to classify or identify a human, how do you do that? Okay, so human, what characteristics the human has? We have ears, we have eyes, we have arms, and if these physical characteristics or physical features are in a correct order, we can identify it as a photo or a given image as a human. Okay, and if you know this specific human in the photo, you can identify this specific human as well. So what we actually the more important thing in learning or identifying something is identifying these features. So I talk about the features like eyes, nose, all those things. But among these features, there are low-level features like that. How do you identify a nose of a person? Okay, so a nose has a specific curvature and it has a specific lines and the skin tones, all those things. So they are low-level features. Okay, so we can categorize the set of features as high-level to low-level features. Okay, so deep learning can identify this hierarchical feature structure in human or any given image or any given data set automatically from the from the raw data. So the low level to high level features are automatically identified. So if we need to do this manually, or if someone is asked to do this identification of high level to low level features manually, it can often go wrong because it depends on the expertise of a specific person. So we give that boring task to deep learning algorithm to do that. So it can identify these features and predict what is the input. So that is the main. That is why these deep learning algorithms are so differentiated from the other machine learning stuff. So talking about why now. So actually deep learning networks were existed since 1950, about 5 decades ago. But the thing is, uh, there are a lot of inventions in the neural networks or the deep learning a few decades ago. However, nowadays people are talking about this deep learning so much. So there are few reasons behind. So one reason is this the big data hype. So we have larger data sets now. It is very easy to collect larger data sets because of the availability and easier data collection and image net like data sets are already available in the internet, so you don't have to worry about the data collection. Okay, and the deep learning algorithms need a lot of data to learn because it learns from the data itself. Okay, so this is one reason. And the hardware support. Okay, so the GPUs or graphical processing units and the parallelization has enabled the deep learning algorithms to work more efficiently. So since this hardware support is there, we can easily implement these deep learning algorithms and we can train fast. Otherwise, this would take a lot of time. Okay. And the final thing is the software framework. So this is the main focus of today's talk as well, to introduce you a software framework and teach you how to build your own deep learning network for a given problem. So the software frameworks like the TensorFlow, PyTorch, and the Keras like that, and also Microsoft also have a Microsoft Cognitive Toolkit. So these frameworks enable faster development of these models. So when someone comes up with a new deep learning architecture, it is very easy to deploy or code these new deep learning architectures into the production. So these things actually accelerated the development of deep learning network in the industry or real world application. So I have a small video I have taken from NVIDIA. So I'm pretty much sure almost all of the people who are listening to this has heard of the deep learning. But I just want to show you guys about the what is the current situation of the deep learning, what is the current innovation. So let me say this. This is not a very long video, I think.
Sir, do the video contain sound? We can't hear anything.
You guys can't hear the sound. Let me check. So sorry, I don't know why you guys not here. But anyway, due to the time constraints, let me run it and enable the subtitles. So sorry about that. Not getting the audio. Actually, the idea about playing this video is to give you the current status of the deep learning application in the real world problem. So anyway, I think you guys can watch this video after the session. So I hope. So let me move to the next section of the presentation. So the deep learning building blocks. So I don't want to be a lecture for teaching the deep learning building blocks. So I'll keep this part short. So I am only giving you the only the necessary parts to continue implementing a deep learning model. So since there may be a lot of people who already know these things, but just to make sure everyone are in the same table. So so this is actually the hello world part of deep learning understanding too. because the perceptron or the neuron is the main building block of any neural network tutorial. Okay, so you will find these terms and everything in almost all the deep learning text and the articles. So this is the simplest neural network component called the perceptron. So you can see we can have multiple inputs. So these 1 to m number of inputs can be supported for a single neuron, and there are another set of numbers called weights. Okay, so this what a neural network does is when you put an input, this value of the input is multiplied with the corresponding weight value, and it is summed at the neuron. Okay, and there is another term called bias. I will explain this few minutes later after explaining this summation and the nonlinearity works. So basically, we are putting inputs and we multiply this input by the weight and get the summation. So at this point, we have a single number. Okay, at this point, we have a single number, and we have a nonlinearity or nonlinear activation function. So we are putting this summed value to the nonlinear function and giving the output. Okay, so this is the basic or the simplest idea behind the single neuron in a neural network. Okay, so giving you the mathematical understanding. So this term actually shows the multiplication and the summing part, and this is the bias term. Okay, so this G represents the nonlinear activation function, and you are getting some kind of output given these inputs. Okay, so so this bias term, it can control the output. So this bias term is not bound to the input. This is something the developer or the machine deep learning practitioner can control. So this weight is not bound on the data set. So someone can control this, and the value you are getting at the output side of the neural network can be changed. So this is some kind of a control given for the deep learning practitioner. Okay, so adding some mathematical parts. So don't worry too much about this. This is the same thing as written here. So I'm only using some kind of a linear algebraic notation. So this is the same thing. So we are representing these features as a vector and the weights as vector as well. So I put these images as well, so it is easy to understand. So what we does is we are getting the dot product of these vectors and getting this. So so I'm using this notation in the next set of slides. So the same thing, we are multiplying the inputs with the corresponding weights and adding the bias term and apply the nonlinear function. Okay, so don't worry too much if you don't understand, because when we do the demonstration, I'm pretty sure you will get understanding when you apply these concepts to the coding. So don't worry too much at the moment. So this is the forward propagation. So forward propagation means we are putting some kind of input and expecting output. So the data flow is from the left to the right side. Okay, so moving on about this activation function. So activation function here, this nonlinear activation function I mentioned a few times. So nonlinear activation function, this is we are getting some kind of a number here and apply the nonlinear activation function. So the behavior of the nonlinear activation function is like this. Okay, so this is the mathematical expression. Don't worry too much about that. But when we plot that in plot that here, you can see this is the behavior. So when we put a number here, it is giving us output between 0 to 1. Okay, so that is the only thing you have to know. So you can consider this as a black box. You are giving it a number and it is outputting another number between 0 to 1. So this is very much important, because I think probably all the people know about the probability. Okay, so when we talk about the probability, it is also between 0 to 1. So that is the main rationale behind this activation function, range in the output between 0 to 1. Okay, so sigmoid activation function is only one of them. There are a lot of activation functions we are using for the deep learning. Okay, so let me show you a few activation functions and the corresponding TensorFlow code as well. So just look at these plots. So these are showing some kind of pattern. Okay, so if we look at this value range, it is actually output number between some kind of small range. Some of them are outputting 0 to 1, some of them are outputting -1 to 1, like that. Okay, so the sigmoid activation function is one thing, and there's a hyperbolic tangent, or we call this a tanh function when we code these functionalities. And there's a popular activation function called the rectified linear unit, or ReLU function. Actually, this depends on the problem. Okay, there is no hard and fast rule for this. This actually depends on the problem where to use this activation function. So I'm pretty sure if you don't even understand these things now, when you're coding, you can come back to these slides and understand the behavior. So you will find the right activation function when you start coding. Although at this point of time you don't understand what is the actual use of activation function. So that's why I included another slide to explain why we need activation function. So you can see this is a data set. Actually, you can consider this is a data set scattered in 2D plane. Okay, so there's a clear pattern like red dots and green dots. Okay, so you are asked to separate the green dots and the red dots. So if we use a linear activation function or a single line, you cannot actually find the correct boundary. Okay, because this is in a very complex pattern. You using a single straight line, you cannot separate these two dots into two parts. However, using a nonlinear boundary, you can find the complex boundary between these two data sets. So using a nonlinearity, you can separate these reds and the green dots into two separate subsets. So that is the most high level idea of using a nonlinear function rather than a linear function, because a lot of real world problems are like this. It cannot be separated from a single line, straight line. We need to have a nonlinear function to do this. Okay, so I think I explained the real use of the activation function. So let me move to the application of neural networks to a problem. So here I am trying to apply this to a actual problem, so you will understand how to apply deep learning to a different problem if you can solve one problem. Okay, so sorry. Okay, so this is a very typical problem everyone has when you learn, when you are in university. This is a typical problem everyone have. Will I pass the subject? Okay, so I know the burden. So one thing you can do is you can ask from your seniors about have an idea. So if I do this, will I be able to pass the subject? So this kind of a previous knowledge is also available. So I am using some kind of a previous knowledge to come up with this representation. Okay, so the red dots here represent the failed students, and the green dots represent the passed students. So I use two criteria or two features here. So feature 1 or x1 is the number of lectures you attended. Okay, and the x2 is the number of sorry, actually this should be number of hours spent in the final project. This is small typo. I didn't see this before. So x2 should be the number of hours spent in the final project. Okay. So using this, we can actually have some kind of a representation. Okay. And this is the purple dot is here. So you have these variables. Okay. So you have you are still studying this subject, but you don't know you will be passed. So you are actually here. Okay. So using this information, will you be able to identify you will be passed or not? Okay. So clearly, using a single line, we cannot separate these dots. Okay. So we should use some kind of non-linearity here. Okay. Using a straight line, it's we cannot separate these dots to a two part, passed or failed. Okay, so we are, since now you guys know how to use deep learning, so let's start applying deep learning to the problem. Okay. So I have a deep learning network. Actually, using deep learning to this network is wrong. Actually, this is a single layer network, so we cannot say this is a deep learning network. So anyway, this is a neural network. So this is my two features. Okay, I have two input neurons here, and I am input this vector to the input neurons, and I am getting a prediction or probability that you have a chance of passing this subject is 0.1. So probably you have very little chance passing the subject. Okay, so this is what the deep learning model says. So now you submit your assignments, you sit for the exam, and you will now have the ground truth or the actual result. Okay, you passed. Okay, congratulations, you passed. Okay, the neural network was wrong. Okay, it said that there's a very little chance for you to pass this subject given the information, but you passed. So what happened here? So I can actually wait about a minute to get an answer for this if someone is giving me the answer. Why this behavior? Why the neural network was wrong? So Indrajit, anyone is giving me the answer, or can I continue?
No, let's wait around 1 minute. They can ask answers in the chat.
Yeah, so no, actually the question even not related to this. If you have any problems related to the previous part, you can ask me as well. So we can have the same understanding before we continue to the rest of the presentation. So the neural network is obviously wrong. You passed. Why? Okay, so I think no one is giving the answer. So the answer was the neural network wasn't trained. Okay, so the neural network doesn't know anything about this previous data. So the neural network is kind of a newborn child now, newborn baby now. It doesn't know anything about that. So we are putting this variables here, and the weights. I actually forgot to mention about this. So initially we are setting these weights randomly. Okay, initially the weights, the numbers of these weights are random. So using that, it cannot give you a correct answer because it doesn't know the previous knowledge. Okay, so obviously your answer is not correct. So the predictions are not correct. To solve this problem, we are actually using this kind of a formula or this kind of a mathematical formula to quantify the error. Okay, so how do we do that? So when so you may remember that when a small child is wrong, so we have to tell him you are wrong, how much wrong, and you have to correct your behavior. Okay, so you are always correcting when someone is learning. Okay, that is the way humans are learning, and that is the way the deep learning networks are also learning as well. So we are telling the neural network that you are this much of wrong from the actual prediction. So this is the ground truth, this is the network output, and we are actually calculating how much wrong the network, and we are telling the network to fix your errors. Okay, you are wrong, this much is wrong, fix your errors, because we need to minimize this loss. Okay, we are saying this is a loss of the network. So this is how we train the network. We are actually still at the training of the neural network stage. Okay, so now we are telling the network to fix your errors. Okay, so we talk about the loss, and we only considered one single error. Okay, so one student is asked to predict his score using the neural network, and he got wrong. So that is only 1 point. So now we are asking more than one student to ask the neural network what will be his will he be passed or not after the exam. So empirical loss here is actually using this same formula to understand the how much incorrect predictions are happening in the neural network, and we are actually using this function to get the average. So don't worry too much about this notation. We are actually calculating the average of the loss of the network, and we are asking the network to fix these issues. Okay, so in normal deep learning textbooks and the article, we call this objective function or the cost function. So this is something important. Okay, so so I'm putting these numbers. I want to check whether these students will be passed or not. This is the prediction, this is the ground truth, this is the reality. Okay, so some of them are correct, some of them are wrong. So using this loss as average, we can ask the network to correct their issues. Okay, so the loss is calculated like this, and like the activation functions, there are a lot of loss estimation functions as well. So these things are used to use depending on the situation, depending on the problem. Okay, so this binary cross entropy loss is used to use for the classification problem. So if so the problem like we discussed, so it is classify pass or fail, 0 or 1. So we are using this binary cross entropy loss function. So it is a classification. So we are using the mean squared error. I am not giving a lot of details about this, how to implement this and everything, because we are using the demo to check these values. Okay, so this mean squared error is used for the regression types of problem. So regression means you are generating some kind of a real value, range of real value. So instead of asking the network to predict whether you are passed or fail, we are asking give me the actual grade, actual mark here. Okay, so you are asking the network to give the actual mark. So this will be the output of real value. So in similar problems, we have to use the mean squared error. So these are two major loss functions, but there are a lot of loss functions depending on the problem. Okay, so building a neural network. Okay, so we are very closer to the fun part now. So we talk about these loss functions, activations, and you know why we need these things, and we are very much one step behind developing a neural network, but still we are not developing a deep neural network. Let me first start by how to implementing a single layer neural network. So these are the inputs, so you know that these are corresponding to the number of features you want to use. So we call this the hidden layer here, because hidden layers are the layers in between the inputs and the output layers. So you can have multiple hidden layers, but here I am only using a single layer, and we have two outputs now. Okay, so the number of outputs, it doesn't matter. It's depending on your design. You can have multiple outputs as well. So as you can see, there are multiple connections between these neurons. So there are multiple weights as well. So these weight numbers are multiplied by with the inputs, and Z1 is the summation of all these multiplication, and we put these summations to the activation function, and these things become the input to the next layer. So this is the idea. So as a chain, you have to calculate these values and can have the final output. Okay, so don't worry about this mathematical notation. So I add the corresponding TensorFlow code as well. So you can map this idea with the code, because it's very easy to implement these things using this framework. So as you can see, I am importing some libraries. I think probably this is very similar to any library importing any programming language. So I am importing some things here, and you can see I am using type input layer as well, and there are two layers called dense layer. So this is the name we are giving to a fully connected this type of layer. Okay, so dense layers are called like that. The activation, I am giving the railway activation function to the press dense layer. And the final layer, I have two outputs. Here I am using the softmax activation function. I didn't mention about the softmax. I only mentioned about three types of activation functions. So softmax also very popular activation function to use for the output layers, and this is also generating the probabilities of these values. Okay, so as you can see, it is really easy to implement these things using TensorFlow and the Keras development framework. Okay, so giving you a smallest change for the previous network, because I thought it will be more complex with these multiple links between the neurons. So I isolated one neuron in the hidden layer here. So you can see multiple three connections. Actually, this could be M connections are coming towards this one neuron in the hidden layer, and there is a weights associated with that. We can calculate it. Okay, and we use the nonlinear activation function here. Generate the value between 0 or 1, or it depends on the activation function actually, and it will be the input for the next layer. Okay, so I didn't include the bias term here. However, in this equation there's a bias terms as well. It depends on the it actually your choice to add the bias term or not. So still we are talking about the single layer neural network. So let me move to a multi-layer neural network. So this is actually actual deep learning network. Okay, so these sections actually shows the hidden layers. You can have multiple hidden layers as you want in between the inputs and the output layers. Okay, so that is why the deepness comes. Okay, the network will be so deep if you have a lot of hidden layers here. Okay, so you have two outputs as well. Yeah. Okay, so this type of architecture we call the multi-layer perceptrons, or MLP. MLP architecture. So this is the simplest.
Before start that topic, I have to interrupt little.
Yeah.
So we have scheduled the session to in 7 p.m. Maybe it can be over in 7 p.m. If it does, our attendees don't be confusing. So
Yeah.
if something happens, we'll do session part 2 in next month or next week, or whatever
sure.
time so free. So
yeah, sure. So how much minutes I have, Indra?
I think there are about 4 minutes. I don't know whether the meeting will be closed on exactly 7 p.m. or not.
Okay.
But
okay.
You can keep going.
Yeah, sure. So So actually, I'm skipping these contents because there are a lot of things to talk, but I'm pretty sure this will bore you out if I going to talk about these things. However, I encourage you to look at these things if you are very much enthusiastic in learning the deep learning, because these things are very important for your knowledge, as well as you can actually pretty much start from learning a deep learning framework. However, you will miss something. So even at the later time, you have to come and see these concepts. So better to learn these things. So I'm skipping these contents. I'm not going to describe these things, and let me move to the TensorFlow itself. So this is the software framework we have been talking about since the first slide. So TensorFlow is the open source software library created by Google in 2015, and this is extremely flexible and efficient. And as you can see, within a few lines of code, you can create a very sophisticated deep learning model, as well as this is extendable. So there are a lot of pre-created deep learning models available. However, if you want your customized deep learning model to create, it is also possible and very easy, and it is also portable as well. So you can create models in your PC, or Macs, or you can port them to the iOS, Android, and everything. So it is very portable as well. And actually, most importantly, it has a large community. So you don't have to worry about when you stuck in something. There's a large community around this TensorFlow. So this is used more in the research, production, and education as well. As you can see in the chart, the TensorFlow is the most popular deep learning framework in 2018. I'm pretty sure these numbers are correct for nowadays as well. So TensorFlow 2.0 is the latest version. I'm not going to talk about this ecosystem of the TensorFlow. The main thing is you are given a lot of tools to work in TensorFlow. You don't have to code your own code unless if you want to customize anything. It is very easily runnable in the CPUs, GPUs, and these tensor processor unit as well. And you can save your models and deploy it in the mobile devices, cloud, and everything. Unfortunately, I am actually using a lot of this left side. Okay, I'm not deploying this in the mobile devices or anything, but I'm pretty sure industry applications use almost all the ecosystem as well. So I'm sorry, I'm not very much expert in this deployment like the TensorFlow Lite and the TensorFlow JS. Sorry about that, guys. Quickly showing you the implementation. I think so. Indrajit can share the links I sent him few hours ago, so others can even after this session, actually others can self-learn this implementation. So I'm using this Colab, the Google Collaborative Laboratory, for the demonstration. The main thing is it is free. You can access the GPUs, TPUs as well, and you can use your own Google Drive. And you don't have to install the TensorFlow and all those Python libraries, and because it is somewhat time consuming, and if you want your own workstation to work with the deep learning model, you obviously need expensive GPU. But this collaborative laboratory provide these things for free. And also you can share your codes, collaborate with the community. This is very much streamlined. So so I suggest you to go to the there are two links I have provided, so you can open your own Colab research Colab notebook, or I have pre-coded some of the things in the code I have shared. So I'm not sure I'm allowed to talk any more than this. So let me show you a glimpse of what I have planned for the demonstration. So so Indrajit, am I allowed to use?
Yes,
few
yes.
Sure.
I think you can take the session.
Sure. So So do I have questions from the audience before continue to the demonstration? Indrajit, do I have questions from the audience?
Yes, we hadn't, but the question and answer pane was disappeared after the 7. So I'll try to get the question back.
Yeah, sure. So I think if the audience are...
The question is available.
Oh, really? Okay.
Hello.
Hello. Yes, I can't
questions are
see.
available. So shall I say the questions here?
Yes, you can.
So one is, how can we decide the number of hidden layers and number of neurons for them in a deep learning model?
Yeah, so actually there's no correct answer for that. This depends on the problem you are working. So it actually really depends. So image data, it will be the number of pixels in the image. Okay, so in the text data, it actually depends. So maybe some of the features are not important as well. So it's problem specific. So the best thing is actually you have to this is mostly a trial and error process, someone would say, because you don't know at the beginning what is the right amount of features, what is the number of layers I should be using, how much time I should train the model. It actually depends. So I think after the demonstration, probably the person who asked the question can have an understanding how to decide this number. So yes, there's no right answer. I don't think anyone can give the right answer for that. Any other question?
Not questions, like there are some statements, but not questions.
Yeah, sure. So let me share my. So this is the Colab notebook. So don't worry if I cannot complete this in time. This notebook is shared, and I added a lot of comments and everything in case someone can self-learn these things. So so let me start this. So am I sharing this? Yes. Okay. So if you can open the Google Colab notebook, actually the pre-coded one, it will be look like this. Okay. So basically, I assume a lot of people have the Python knowledge, but Python is a pretty much easier language compared to the other language. So I don't think it will take a lot of time to learn the Python code because it's mostly self-explanatory. So first code section here. Actually, I'm importing a lot of libraries to the notebook. Okay, so I'm importing TensorFlow and the Keras as well. This NumPy is the numerical Python package, and the Matplotlib is used for the visualization process. And from Keras, I'm importing these models, like the model and the sequential input layers, dense layers. Dense layer is the layer you have seen previously in the slide set. The flatten layer, I will explain this, and some utilities as well, and some scikit-learn package to generate the classification report. Okay, so I am using actually image data. I didn't explain this in the slide because it is somewhat difficult to explain without proper data set. So I'm loading some data. So obviously you need a lot of data to train a deep learning model. So fortunately, TensorFlow actually comes with the preloaded data sets. So it is very easy to load some kind of a data set and make use of them. So let me run these things. May take some time because I'm running this first time. Okay. Yes. So you will get this kind of information. It is using the TensorFlow backend. Okay. And I am running. I'm actually loading the data as well. So what this does is this is downloading the data set from distance location and loading to the our development environment. Okay. So now we have the data. So first we have to look at the data. Okay, so this is relevant to the question I was asked about the features, the right number of hidden layers. So first we have to understand what type of data we are working. So I'm running this code. So extrain. So sorry, I forgot to mention what happens here. So what this does is this actually separate the data set into the two major modules. Like what are the data to use for the training of the neural network, and what are the data to use for the testing of the neural network. So extrain, this data structure contains all the images. Okay, so if you can see this pop up, it is ND array with shape 60,000 by 28 by 28. So 28 by 28 is the resolution of the image, and we have 60,000 image data set here. So it is a pretty huge data set. However, these are very small images. So the storage wise, this is not a very big data set. However, number wise, this is a pretty huge data set. And why train are the labels. So this MNIST dataset is a dataset which contains the handwritten pixels. Okay, so handwritten pixels. So it has the image as well as what is the actual number. Okay, I will show this. And Xtrain, Xtest has also 10,000 images as well. So Xtrain has a 60,000 and Xtest has a 10,000 images. So this is a very large data set. Okay, so the same thing, I am actually getting the shape of this data structure. The shape is basically how many images and the resolution. So 28 by 28 resolution. So this has basically 28 pixel for the width and the 28 for the height. So MNIST dataset, I put some information. So in case I didn't have the time to explain this, so I'm plotting an image. So this is a typical structure of an image. Okay, so you can see there are 28 pixels here and 28 pixels here. So the one thing you have to understand is these values. Okay, so these values are between 0 to 255 range. So this is actually two-dimensional matrix, even though we see this as a image. So this is a two-dimensional image. So this has values between 0 to 255. The thing is, deep learning network doesn't like this type of very high range. Okay, so what we have to do is we have to apply the normalization. So don't worry about this naming. So what happens in the normalization is I'm converting this image. So the values would be between 0 to 1 scale. Okay, so so after the normalization process, it is pretty easy to work with this data set. Okay, so what I do is I am dividing the entire two data sets, the training set and the test set, by 255.0. So this is a metric operation. This is applying to the entire 60,000 and 10,000 training and testing data sets. And you will have a normalized version of the same data set. Okay. So we are actually, we call this process the pre-processing. We are not still using this for the deep learning network. We are preparing the data to use for the deep learning network. And we actually normalized and we prepare the data for the images only. So how to do that for the outputs? So currently, this is the structure of the outputs or the ground truth. So you have the image here and the label here. Okay, so we have digits from 0 to 9, but we need this type of a representation. Otherwise, the deep learning model doesn't understand. So the difference between this is this is a binary matrix, so which have 1 for the corresponding image. So if the label is 0, I put 1 here. If the label is 2, I put 1 here. So all the rest of the positions in the matrix are zeros. Okay, so this is also very easy. I'm only putting this picture to show you what's happening in the one-hot encoding. So this I imported this two categorical method from the Keras utils, and using this, I can convert these labels into the one-hot encoding model. Okay, so our pre-processing part is now complete. Okay, now we are ready to create our deep learning model and use this data. So I am building this model. So as you can see, the input shape, this is the dimensions of the input shape. So it is 28 by 28 input. So this is the resolution or the dimensionality of that image. And I am using a flatten layer here. So what does flatten layer does? So this is what the flatten layer does, because this is a sequential model. We have to convert this type of a two-dimensional data into a one-dimensional array. So this is actually what this does. Okay, so this two-dimensional images are converted into one-dimensional array. Okay, so this model doesn't do any deep learning stuff. This is also kind of a data transformation stuff. Okay, and I am inputting two layers here, two dense layers. One has the ReLU activation function and the other has the softmax function. So let me run this. Okay, so using this model summary, I can have an idea about what type of network is generated after this. Okay, so I ran that. So this is the summary of the network. So this is a word of advice where after you creating your own model, just run the summary so you will know what type of a network you have created and these parameters as well. Okay, so this is a very simple network, so I don't have a lot of information as the model summary. I put some information about what does this what does each layer does. Okay, and you now created this, and model compilation need to be happen. Okay, so this optimizer loss and the metrics. So you know about the loss function. Now I mentioned something about the loss function and what is the real usage of the loss function. So this is a categorical cross entropy loss because we have 10 outputs now. So this is a classification problem. So we have 10 outputs now. So this is we have to use a loss function which can be supported for the 10 outputs. So categorical cross entropy is something which we can be used for 10 outputs. Okay. So this optimizer, I actually didn't have a time to talk about how to optimize, how the optimizers are working. Actually, what this does is this depending on the loss, actually it recorded how recorded it is updating the weight. Okay, so you know that at the very beginning of the neural network training, these are randomly assigned, so we have to update. So we have update so that the loss will be minimized. So ADAM, or the adaptive learning optimizer, is one type of optimizer, and this is also a very popular one. Almost a lot of works are using the ADAM optimizer. So let me compile this, and also this metrics. So these are the outputs of the training. Okay, so I am actually interested on the accuracy of the model, how much accurately classify these digits. So that is something I am interested in. So let me run this. Okay, so model fitting. So after you compile, now you can use this data to train the model. So we are now training the model. We are teaching the model how to identify these handwritten digits. Okay, so I put these data to training sets. So this is the actual images. This is the labels, the one-hot encoded labels. These epochs are actually the network is running 3 times using the entire data sets and stops. So 3 iterations. It's like you are putting 3 for your for loop. And the validation split is taking 30% of the training set to validate the model. So it is using 70% of the data to train the model, and it is testing how much it is working, how much it is correctly classifying the data from the 30% of the data. Okay, so I am running the model. Okay, getting some kind of error. Okay, so this type of errors are actually very common. So mostly I am not matching the dimensionality of the data inputs with the actual data set, I think. So the problem should be here. Okay, so I was wrong in this train. Okay. Okay, my Y train must have an issue. Okay, so it's working now. The issue was I ran 2 times the same code, so it was assigning the, I am using the same variable there, so it is reassigning the values to the same variable. So okay, so our network trained. Okay, so it ran 3 times. You can see the output. So this is where you have to make the decisions about the training. Okay, so the one thing I am looking at this, the loss. Okay, so you have to reduce the loss. Okay, and we can see the number of loss is actually reducing. So that is very good thing. and the accuracy. Okay, this is the training accuracy. It is improving. So this number is actually 97%. That is very good result. Okay, so the validation set, the 30% validation set we provided, it is also showing something similar. The validation accuracy is also improving. So we have a 96% 53 accuracy with 3 iterations. So the 3 epochs here. Okay, so that is a very good thing at the, because we ran this model 3 times and we are already getting some kind of a good result. I'm running the test set now. Okay, so I have a test set with 10,000 images. I ran that. It took very small time here, and I'm getting this type of accuracy here as well, 97%. So actually, model learned from the data. As you can see, I only put the normalized image set as the input, and it learned these features, and it can even predict the unseen set of images and give me a 97% accuracy. That is very good thing. So let me have a look at these predictions. Okay, so I can see this is the label. 0 has high precision, like all. Actually, this is a very good result. I don't have to interpret one by one. All are actually getting more than 90% precision recall, F1 score, and overall accuracy. So this is a very good result. So I'm running few more codes as well. So this is the input. So so can someone say what is the number? As a human, we can also identify this. What is the number? Can someone say, Indrajit, are you available? What is this number?
Yes.
Yeah, what is the number you can see from this digit in the screen?
I think it's most like 7.
7. Okay, so let's see our predictions are correct. Okay, so it is 7. So model works. So works. Actually, we qualitatively tested only one result, but we have 97% accuracy. So only the 3% of the images are misclassified. So this is a very good result. Okay. So I can, if the organization wants, if I can allow more minutes, only I can cover about by 5 minutes. But
Yes, you can have.
yeah,
No
sure. So so we have kind of a very good result. So I just wanted to give you some kind of tricks to identify the performance of the model so you can improve. Okay, so this is an iterative process. As I mentioned, this is a trial and error most of the time. Okay, so as I have shown, this is a very rare situation. You are getting a 97% of accuracy. So when you work with a new problem, you will never get this type of a high accuracy from your first implementation. I'm pretty sure. Okay, so you have to spend a lot of time working with these variables, changing these variables. Okay, so I just wanted to give you an idea how to do that. These are very basic things people do to identify the performance of the network. Okay, so so I am showing some kind of a chart actually. So this is the validation loss and the test loss. Okay, so the loss should be minimized. So with the number of epochs, number of times we ran the same model, actually I only ran 3 times here. More normally we have to run more than 100 times. Okay, it is a time consuming process. So if the if the loss is getting lower corresponding to the epoch number, your model is actually working as it is expected. Okay, so this model actually obviously very good model here. And the accuracy, okay, I am not actually explaining this code, so sorry about that. However, I think this is mostly self-explanatory. I put some comments as well. So I'll give you some time if you guys need some explanation about these things. So I'm only explaining these things due to the time constraints. So you can see the accuracy actually improved. Okay, This is the first epoch, this is the second, and this is the third one, accuracy improved of the model. So this is the expected behavior. So I am going above and change the epoch number to 100. This will take some time. So meanwhile, like you guys can ask me questions, or if the organizers has any announcements, you can actually continue, because this process will take some time. So I can give that time to discuss anything related to my talk, or if the organizers have any announcement to give, you can utilize this time. Indrajit, you can have this time. If I have any question, I can answer.
Yes.
But this will take about few minutes.
Gihan, do we have any questions? Because I can't see the question.
Yeah.
We have several questions.
Okay.
So
okay.
how can we select relevant features only to build a model to specific requirements?
Can you ask the question again? I really didn't get that.
How can we select relevant features only to build a model to a specific requirement?
Okay, actually it depends on the specific requirement. So as I told you, so the multi-layer perceptron, or the model I am currently working, is the most simplest deep learning model. Okay, so it can actually give you pretty much the very good accuracy, but normally there are a lot of architectures. I will give some kind of summary about the types of architecture. So if you are working in the image data, you can use a specific architecture. Okay, so the thing is, you can have a lot of image data, because there are a lot of data sets. Most of the time, if you let's say if you are building a model for your mobile phone to identify your face, so you are basically using your camera to capture image, and it will be the image data. Okay, so the process about how many features will be the same process I have used. Okay, so it depends on the number of pixel, depends on the resolution. Okay, and actually it is experimental. Okay, so you can see I actually did everything one by one, and I actually went back to the previous step and changed the epochs, number of epochs. So I want to see how much improvement I can take. So actually it is problem specific. So if you can explain me what is the actual problem, what do you want to do as the task, you want to classify something, I can give you a better answer. It's very hard to answer this very generic question, because it depends. Yeah, guys, any other questions?
Yeah, there's another one.
Okay.
Is there any recommendation on book or courses for beginners and
sure.
for ones who wish to continue their studies in deep learning?
Yeah, sure. So I have in my presentation I have so what is the epoch I am in? So I have I included few of those things as the last slide of my presentation. So since you asked, I mentioned. So you can there's a very good course. I even borrowed a lot of contents from their course as well to prepare my slides as well, because very explanatory. So there is a free course. It is not free. The course contains the lectures, the lecture materials are free, offered from MIT. Okay, so it is a short course. I think you can complete it by within week, because it is they explain it very well, and they are using the Tensorflow and everything as I used. So I'll give you the link at the end of the presentation. And as for the books, so if you are more into developing these things, so probably the Keras book will be useful. So its name is The Introduction to Deep Learning. I have that link and the image of the book at the end of the slide, so I will show you. So it is a very good reference. It doesn't use a lot of mathematics, and you can straight away use the Keras and start building models, and also learn the deep learning when you start coding. So, and there's another book if you want to use deep learning for your research. Okay, so its name is deep learning as well. So there are a lot of materials available in the internet, but so far the best course I recommend for anyone is the MIT deep learning course, and there's a Coursera offering of Stanford deep learning as well. The thing is they are using MATLAB instead of Python, so it depends. Actually, if you want to learn deep learning using MATLAB, it's possible as well. But the thing is, um, I think majority of the community is now using Python for deep learning, so it's easy to stuck with the majority's choice, because when you are stuck, you have to obviously look for answers in Stack Overflow anywhere, so it will be so easy. So if you want, you can actually contact me offline as well. My email address is there, and you can ask the organizers about my other contact details if you want. So I will share the slides after this session. So very much like to help if anyone is willing to learn more about the deep learning and want to use the research. You want to use that for the research project or any industrial project as well.
Yeah, we have another question about the error you got.
Yeah.
So
yeah.
one curious question: how did you fix the error?
Okay. So the error was probably my silly mistake here. So the error happened. Yeah, here. So as you can see, I am using the same variable to assign what is the output. Okay, see, this has the same name. So what happens was, if I run this twice, I'm inputting the same output to the input. Okay, so what this function does is they apply twice the same thing. So that's what happened. So the fix was actually I reinitiated this variable by reloading the dataset and reran, because mistakenly I must have clicked this button twice, so it ran twice.
Yeah, we have one final question.
Yeah.
Do you recommend to go through fast.ai GitHub repo as a starting point?
I have only heard about it, but I never had a look. So I really couldn't give a straight answer for that. But if it has a good explanatory explanation about how things work, how to apply that, and also some codes to refer. So you can actually refer these mathematical models into a practice if you have the code straight away with that. So probably that will be a very good resource. So I'm really sorry, I only heard about it, I never used that, so cannot give you an answer. But yeah, probably just contact me if you want, so I can have a look at it and give you some kind of a comment about that. So I think my model has completed. So I put 100 epochs. Okay. So let me again go through the losses and the accuracies. Okay. So I almost get 100%. Sorry, I got 100% accuracy for the training. Okay. And 97 accuracy for the validation set. So this hits the highest bar. And let me check the loss functions as well. So loss is extremely lower now. See, minus 0.6. So this is very small loss. So we can decide that our deep learning model is performing very well. So I have this. Let me rerun my plotting functions. Okay, so this is plotting function. So I now have 100 epochs. The validation loss is gradually decreased and stabilized. However, you can see this test loss. It is increased. This is not a very good thing. So test loss should be decreased as well, gradually decreased as well. So it should be aligned with this. It should be it should maybe align with this or going parallelly, not converging. However, this behavior is not a very good thing. However, if you can see the range of the change, it is not a very big change. Okay, it is only ranging between 0.1 to 0.2. So that is one observation. So you have to do something about that. And let me check the accuracy. Okay, so accuracy kind of good. For the training accuracy, it is mostly stable with small fluctuations. However, validation accuracy, I'm not very much happy about this because there are some spikes here, which is not very good thing. Okay, so I actually want to show this observation because you guys are asking how to tune this, all those things. So you may think that this is very straightforward because I got a 97% accuracy at my first run. This is never happening in real world problems. So only for this specific problem, this can be observed. So this we call this gap, we call the generalization gap. Okay, so this gap need to be minimized as possible if you want to have a very good model. Okay, so to improve the model performance, I'm actually not demonstrating these things, but you can actually search Google and look at the books. I am going to suggest you this. This show how to add these fixes to reduce the generalization gap. So one thing is adding a regularization term and early stopping, and the adding dropout layer. So early stopping I can actually describe with this example. So here you can see in the loss function here at the very beginning the gap is smallest. Okay, gap is extremely smaller than the this position. Okay, so at this stage, if we can stop the model training and take out the model for the prediction, that could be a better model. So that we call the early stopping. Just stopping the model training very early if we detect abnormal behavior, and adding regularization and the dropout are also something similar. So all of these above are considered as the hyperparameter tuning. This takes a lot of time. Okay, so so I think this is the end of this end of the demo. So let me stop this and move back to the presentation. Okay. So so overfitting, I actually almost forgot to mention about this. So overfitting is actually model is too much relying on the training dataset than the testing dataset. So I'm not going to explain because I added the same how to reduce these issues. So overfitting is one possible thing. So we have to come up with this right fit. So this is underfitted. This is the overfitted network. So we have to find the right fit between these two. So you can use the same steps to achieve this goal as well. Finally, so this is the answer for a question I was asked about what type of courses you should be taking. So this is the best course I am recommending anyone in any stage. Actually, even if you have zero understanding, this is a very good course you can start. And this is a book published by the Keras developer, actually Francois Colletti. It's the one actually developed the Keras framework. So this book is very popular. Okay, you can I think you can find a PDF in the internet, and this is very good reference, very easy to learn. Okay, so I let me mention these things. So I only talk about the MLP or the simplest type of deep learning network, but in practice for the image data, I should be using this convolutional based architecture. So it has a different working. Okay, it is not working same as the MLPs. And for the time series data, I should be using the long short-term memory or the recurrent neural network like architecture. And nowadays, actually, the generative adversarial learning GANs are the most powerful addition for the deep learning family. So this is the future directions, guys. So there, I think a lot of people use these architectures for industrial application as well as the research. So I don't know. There may be very powerful models coming in near future as well, because it's extremely active and hot research area as well. So that's it. Sorry if I took longer time than I was allocated. So thank you everyone, and I should also thank for the content I have taken from this MIT course. Have a look at it. And again, once again, thank you all the organizations and MS Camps for giving me the chance to talk with you and share my ideas. Hope it helps for your industry or academic projects as well. And I will be sharing these slides with the organization, so you can get that as well. So thank you everyone.
Thank you, sir. We got good questions which proven the session is success, and hope you all got the correct answers for your questions. Before winding up, we would like to thank few people for get this done successfully. First, a big thank you for our honored speakers, Mr. Isura Nirmal and Mr. Sajeetharan Sinnathurai, for accepting the invitation and giving you a valuable time for us. Second, a big thank for all attendees committing your time and joining with us. Finally, I would like to thank all MSPs, Microsoft Student Partners Sri Lanka, Gyan, Prabhat, and everyone who helped to make this success. So let's wind up for today. Have a nice Sunday and weekend, and we'll join with another meeting. Thank you.